introduce themselves. So, Pere, would you like to go first?
Sure. I'm Pere Monclús, CTO and co-founder at PlumGrid. At PlumGrid, what we do is we focus on creating SDN solutions for private and public clouds, especially now with the movement of NFV focusing on service insertion and some of the topics we will cover. Before that, I was a distinguished engineer at Cisco, and in there I was architecting some of the network functions, especially the ones related to security, high-performance firewalls, intrusion prevention. And I came upon the topics that now we are going to debate a lot very close in terms of how those network functions had to integrate. And I guess we are going to discuss today on the topics that we didn't solve back then, and now some people are solving them in the community, and how this is shaping the industry on the network function virtualization.
Thank you. I'm Joel Halpern, a distinguished engineer with Ericsson. I've been building routers and routing systems for a very, very long time. More recently, I've gotten involved in SDN in its various aspects. I'm a very active member of the IETF Service Function Chaining Working Group, where we're trying to define an interoperable data plane solution, interoperability being the key word in almost any IETF work. I also do policy work and other related things, which all are part of making these solutions actually work for us.
Uri Elzur, I'm with Intel, CTO for the Data Center Network Solution Group. It's a little bit of a mouthful, but what we do is we work on the whole stack for SDN and NFV, from the menu layers, OpenStack, Open Daylight, where I actually am on the board and the TSC. Also co-editor for the network service header draft in the IETF, the same work group that Joel is part of. So we are involved with service chaining implementation from standards on one hand and code that runs either on an SDN controller or on servers. So hopefully you guys are going to enjoy the panel today.
Great, thanks. So we're going to start with just maybe providing a rough definition of what SFC is. And I think most of us understand it as a way of doing service stitching for VNFs that you can then create and deploy on demand. You create the service graph that is used for various VNFs. Is that the right way to think about SFC, or should there be other ways to look at it?
So the way I tend to look at it is particularly focused on service function chaining is about applying network functions, capabilities in the network, to data traffic that is addressed to other endpoints. So for a traditional NFV deployment, the packets are addressed to the function, whether they're packets from the user or packets from one function to another. In the SFC case, we're still talking about mostly virtual functions. Obviously, we allow legacy functions and we allow physical functions, but we're mostly talking virtual functions. But the packets we're handling are those from the user that are intended for some other endpoint in the network, but we want to apply services to them in the middle of the network. That's why the phrase service insertion is often used. And the point of service function chaining is to direct the traffic to the correct places. Having tried to build solutions that inserted traffic control, service control in previous incarnations, it was a nightmare. People do it. Lots of people have service function chaining solutions right now, and they have all sorts of difficulties.
So maybe can we use the slide? Because I think we may go back and forth to that slide just to help those who have not seen it before understand what it is doing, the way Joel described that, and then how it relates to OpenStack and some of the challenges and all of the many opportunities that we all have with this kind of a technology. So simply by ways of introduction of this slide, as you could see here, we have some clients or some consumers or some entities that could be your cell phone that is trying to actually reach out to some server that provides whatever service. Could be simply you are trying to surf the net for something. from the operator point of view, before we allow you to do that, we need to do many things. We need to make sure you have been authenticated, you bought that service, you're not posing a threat to the network, and so on and so forth. So when new traffic comes in, I want to potentially send the traffic to all of those little stations that are going to do different things for their traffic. I could do something very simple. I could say, oh, that person has Note 7. Before there is a problem with that device, maybe I could do some video, but I need to actually make the best adjustment for that characteristic of that device in terms of the video quality, the drivers on it, and so on and so forth. So the red traffic may go and do some type of series of checkpoints or processing, while the blue one may have a different one, depends on the service you're doing. Before we had that, and that actually a slide, Joel is with Ericsson, as he pointed out, and the first place I've seen that slide was from Ericsson. That idea that the red, as an example, goes through all the stations, but the blue doesn't, is right there a big saving, because before I know the traffic, I'm going to send each traffic to all the stations, meaning I have to set up my infrastructure for peak on all the different things I'm doing. With this, I'm actually setting the infrastructure sized the right way for whatever pieces of traffic each of those need to see. There are many other challenges and opportunities here. We'll talk as the panel progresses. I don't want to talk for too long of a time right now, so Barry.
And I will just echo a little bit what Joel was saying, is that network service function chaining, it's a concept, right? It's the ability to create services beyond the traditional forwarding capabilities of networking. And what happens is that in the industry, what we try to do is to add new capabilities like security, scalability of applications, and things like that. And if we add them from a policy point of view, since there is a business case to be made about that, what happens is that implementations go ahead of standards. And this is where definition starts to diverge. There's a proper way, properly sanctioned by ITF and standard bodies that are going to define how to do things. But then there are the realities in the ground. It's like when applications get deployed, when network functions get deployed, people want to stitch them, and what you have is a community of vendors providing network functions that some of them may support the proper metadata, some of them not, some of them may have legacy ways of thinking. And it's an interesting aspect on how the community from a standardization point of view evolves, and the deployments and the prototypes and the early production environments happen, because both things kind of fit on each other as we learn more from real deployments and from standardization. So now service function chaining, I think, is kind of widely accepted as one of the fundamental elements that has to fuel this new evolution of networking and service providers, from the ability to create new service model, marketplaces and things like that. And echoing Joel that both things are important, and sometimes reality is more complex than the proper way of doing it, and now we have to figure out how to take there as fast as possible.
So that brings a good point. So if you were an OpenStack operator and you want to do service function chaining, are there considerations in how one should look at how to stitch these functions together? Are there, are these topology based? How do you decide how to define that flow through your virtual topology? Who wants to take that?
So the way I tend to think about it, and I think this is helpful for most people, you first define the services you want to deliver, what functions you want applied to packets. And so one of the first things that OpenStack becomes responsible for is to make sure those service functions are available in the network. So if you need more of them, make sure they're available. If for other policy reasons you want them in different locations, OpenStack has the mechanisms for deploying that. So OpenStack drives that, and then mechanisms like service function chaining from the IETF and the NSH header allow us to flexibly forward the packets to the places we have put them, arranging things so that we have an efficient placement, so that the OpenStack techniques know where to place the functions so that we can efficiently deliver the packets. That is a complexity that we are beginning to address, but the standards aren't even talking about yet. But what NSH gives us is a mechanism to specify the sequence of delivery independent of the underlying data center or even inter-data center topology. So we're not bound by the physical topology, much the way when you use Neutron to create an overlay network, you're independent of the underlay network. But in this case, you're creating not just connectivity, but a forwarding sequence using NSH, and you drive that from a classifier which puts the NSH header on the packet, and it lets us put in metadata. One of the problems people talk about is, but all these service functions are too closely coupled. Well, first off, do some design work so you can cut them, and then use metadata to enable you to carry information along there.
So yeah, Uri, maybe you could elaborate on NSH a little bit more. What is network service header?
No such header, you mean? So before I go to NSH, and this diagram is going to serve us in order to really follow some of the work we are doing with NSH. I want to first point out a few additional aspects that are related to OpenStack and the way it deals with this. So first of all, I'll start with the notion that this is potentially exactly with that example of your cell phone trying to connect to some internet service. This is an end-to-end architecture. You could actually deploy it, not that anybody is doing it today. As Pere and Joel mentioned, people are doing it in proprietary ways right now, but you could actually deploy it beyond the boundaries of a given OpenStack deployment. So while OpenStack would, many cases, be geographically limited, this is not. So you need to think about it, first of all, from orchestration point of view, as I need something top-down that is able to understand where I want to deploy what pieces of my service. Now let's confine our views just to that OpenStack instance within which I would like to deploy potentially the whole service, potentially a section of that service. I have multiple service functions here. You see service function 1 and 2 on the slide. I first of all need to understand what amount of traffic, what amount of processing I'm going to have there. It may mean that I need to have a way to sometime, and Joel was talking about placement, and we do not necessarily have easy answer to that right now within OpenStack. My ability to say I'm going to place these two next to each other, we have zones and things like that, but it doesn't really make it easy for me to express what are going to be my HA requirements, what's going to be my scale up or scale down requirements, and do I really want these two service functions to be on the same platform, in the same rack? So how does the logical architecture relate to the physical architecture? Moreover, if you look at Neutron and you're doing some sort of a logical network, overlay or whatever you want, and NSH, and we'll get into NSH next, is kind of an overlay approach. So how do I actually make sure that I even have the bandwidth? And what happens when the traffic really gets much higher and now I have to traverse multiple nodes and I don't have a way to control that? So the normal way we deploy is like we are always over-provisioning of the bandwidth is the way we actually do this, so I don't need to worry about that. If you really have data plane intensive activity, you better be aware of that. So there are some challenges here. Some of them come from the telco world, some of them, so I have a larger scope, some of them come from the fact that OpenStack is individual VM/container aware, is not really providing a good holistic placement or control or management solution for a group of VMs or containers. And then I simply don't want to take too much time. I'm happy to continue to NSH, but...
Yes, maybe before we go into the NSH, I mean, sometimes service function chaining, it becomes an overload term in the sense that it is a mechanism to basically wire things together based on some sort of policy that is going to classify traffic and send it, how to carry metadata in a way that you can compound the capabilities of multiple of them. Now, the question is, what's the use case? Why are we doing that? And a lot of times people associate NFV with service function chaining as one and the same, as the ability to solve all the network function virtualization problems of the world. But you have to always think that this is a mechanism, is a way to, as Joel was explaining before, redirect the traffic based on certain requirements, policies, use cases, that in a way that you are going to enhance the value that you wanted to offer in that service. If you focus on that, then there's clouds that have nothing to do with networking, network function NFV, that could be, let's say, an IT cloud where I have my containers and VM workloads running an Apache web server, doing some sort of shopping basket, and now suddenly I want to secure it. And I want to secure it in a way that I don't want to alter the topology of that application. So then I could express a policy that redirects the traffic into a firewall, and if the firewall may be transparent, you send the traffic back, and now suddenly you secure your application. So somehow the mechanisms that SFC provides, they can be used for many things. And this is where the placement aspect becomes relevant, because if you think, in this case, the picture that you have in the whiteboard, clients and servers are on the sites, and then your cloud is running only network functions, this could be an NFV use case using SFC as a mechanism to solve the problem. And now you'd schedule that the east-west traffic, basically the traversal of all these functions, is proper. You go to another completely different use case, which is I want to secure my VMs running in OpenStack. Now the placement of those network functions may be fully distributed in the compute nodes themselves, or they may be centralized into an array of things. So the mechanisms that we are discussing, when you see pictures like that, they feel fairly straightforward. You stitch function A with function B with function C based on some sort of redirection. You carry metadata, but then you have to tie the placement and the optimization and the scale out of those network functions to the specific use case that you are driving. And this is not necessarily only for the NFV community, for service providers. It's the ability to enhance your capabilities to your applications regardless of what's the use case that you have in a cloud. And OpenStack is one of the main drivers for those.
So I mean, obviously interoperability is extremely important between different VNS from different vendors, as well as SFC and how perhaps vendors might implement NSH. I hear OpenStack, IETF all being mentioned, and I know there is Etsy, OPNFV, Open Daylight. There are many groups, Mano on the orchestration side, eComp, right? There's a lot of different initiatives, it seems like, between open source initiatives and standards activities. And maybe you could shed some light in terms of, as an OpenStack operator, how should you be looking at all these different initiatives, and how do you track all the development and all the definition perhaps that's going on between all the different groups?
Do you first want us to spend a minute on NSH
Yeah.
intro? So
Why don't you start with NSH?
Yeah.
Before we get into a topic that we cannot get out, you mean?
Yeah.
So this slide is going to be your quick guide to NSH. There's much more to see about that. But you could see few of the key architectural components that we have over there. As an example, we have two classifiers here. When the traffic enters into the NSH domain, the first action you take is to classify it, which really means having the ability to decide what subset of my traffic should be subject to what policy that I may have set aside, which is going to determine what services I want, in what order, and then I would subject that subset of my traffic to a given service path that here is exemplified by these colorful snakes that are connecting the different service functions. But the key element in the architecture that is dealing with the forwarding decision is the service function forwarder. That is an element that understands the topology. NSH is transport independent, which really means I could stitch together different pieces of the network where I have this service here and that service on a completely different transport. It is kind of, think of it as a service type of an overlay. So I create myself a little service domain, And that domain that really sits in this particular diagram between the first classifier, the outbound of that first classifier, to the outbound of the second classifier, which is optional, is really my domain. And within that domain, everything is being forwarded by those SFFs. And I could have native service functions that are aware of the NSH. NSH has a specific header format. The header really carries the information of the path that you need to traverse, but that is only understood by the SFF. A service function is like, the model is go create your service function, create your differentiation, and the NSH architecture is going to make sure that the right traffic is plugged into it. You don't need to worry about that as a service function provider. But in the transition, as we go into this type of standard-based service functions, I may have some service functions that are not aware of that header yet. And for that piece, we have created the notion of the service function proxy that really sits in between and would absorb those packets that have the headers, strip them off, provide a native packet, if you want, to that service function, and on the way back would encapsulate again the header. So just a 2-minute intro to the way the architecture works. And anything you want to add, Joel?
So I believe you touched on it, but I want to make clear the net effect is that NSH creates an overlay structure. We use the transport mechanisms that exist in the data center, whether they are neutron transports or even lower layer transports, to provide connectivity between the SFF so that the NSH header represents the forwarding within the overlay that represents the service chain that we're sending the packet along, the service function path, to be more precise, and has an index even to represent the position on that path. And one of the nice things that does is if you have either a mixture of data centers or a data center that is itself using a mixture of transport technologies, you can still run NSH over the whole thing and run the different transports as you've chosen. So it works with your data center infrastructure, your networking, but creates an overlay that delivers service function paths.
And maybe one more point that is on the slide, but we forgot to mention, is the notion of the metadata. And the metadata, as you could see in this example, we have DPI as the second function. Obviously, it's just some sort of an arbitrary position. But the key idea of the metadata is that you may have already accumulated some understanding that has to do with a particular flow, set of flows, a particular packet, whatever is the right granularity for your case. And instead, and that's another saving that that architecture provides, instead of having to recreate that in each and every station, because I don't know what is the policy associated with it, or I need to actually send it out of band. So while I show you a nice data plane story, there is a complicated control plane because I need to time it in the right way. Oh, a new flow just started and I need to make sure the policy shows up exactly at the same time so the service function would know what to do. Should I drop this type of packet? Should I not? All of those kind of things. You could embed in the metadata few of those things. And we have few structures. It's not the time and place to go into the details, but just to give you an idea. And so when we talk about the way OpenStack supports these kind of things, we are kind of raising here issues of placement, of SLAs, of QoS, of the ability to actually define the policies externally and inject them into the data plane, the ability to create metadata and how this is supported. And as a community, we have, I think, some future progress we could all do in order to support all of those.
And so if we take that and we talk about the question that Wendy asked, which is how do all these open source and standards components relate? We've been talking about the data plane standard. We're going to define somewhere control requirements, But then if we're going to get interoperability, if we're going to be able to use either OpenStack directly or ODL or ONOS to control these, we're going to need interoperable control interfaces and control abstractions. In fact, arguably more than the control protocols, it's the control abstractions we need to get so that the different mechanisms can all be manipulating the same behaviors in a consistent fashion. And there's a lot of work to be done on that. And it's collaborative work between the open source activities, which are moving these control activities forward, and the standardization activities, which provide a way to actually define abstractions that are useful for more than one open source. And so it's that feedback between the two sides that's going to lead to stronger solutions that can get all the way from the policy definitions and the orchestration control down to the data plane behavior you need.
And taking a more practical approach and echoing what Joel is saying is, it's good to start thinking these abstractions and how to map them to the multiple ecosystems from an open source point of view, and how do we start converging them. Being a small company, what happens is that now you start talking to customers, to different projects, and everybody has a different flavor of those orchestration environments, and they all have their slightly different models and integration requirements. So if we have to move this community forward, if we have to start creating value out of these technologies and these mechanisms, we have to make sure that we don't start sprawling in terms of control structures and model integrations. Otherwise, we cannot follow. There's too many of them. We have to test too many combinations. There's too many requirements that come. So we have to figure out how, from an OpenStack point of view, which kind of is the centerpiece that is being used not only from infrastructure as service, but going into OPNFB and into all the NFV environments as kind of a standard environment for the virtual infrastructure manager. How that, when we start growing up the stack and we are starting to find the frameworks that are going to manage those network functions and orchestrate them, how we don't overlap between projects. And especially because now we have here the Big 10 with lots of projects. One of them is aiming at service function chaining and service insertion. But at the same time, there's a lot of service providers working on frameworks that are going to define that too. So basically, the aspect that we have to bring is how do we bring the definitions from the standard and the models and the abstractions from an APIs that we are going to create. And now maybe we are a little bit more loose in terms of what's the right piece of code to implement a specific model, a specific API. Because otherwise we are going to get caught into too many of those and we will not be able to manage the complexity that arises from that.
So I'll give you a somewhat different take, different cross-section of the way the industry looks right now. Starting from silicon, because we make a little bit of silicon here and there. There is support in network cards, there is support in switches that you could find in the industry for the frame format of NSH. It also takes a slight variation of the popular VXLAN, something called VXLAN GPE, because VXLAN didn't have a next protocol field to it, so we had to change that. So I do have basic support in multiple companies, actually, silicon. When you start looking at vSwitches, life starts becoming a little bit more interesting. There is a work in progress in OVS. This is work in progress for a long time, and maybe one day we'll get there. There is full support today with FDIO. Actually, we have few talks on FDIO here in this event, including one tomorrow if you're interested to learn more about that. Supports SFC with the NSH format. Going to SDN controllers, there is support in Open Daylight, fully compliant with the IETF. Going to OpenStack. In OpenStack, we have few different initiatives right now, and as Joel pointed out, what we really need to enable let many flowers bloom, we need the right abstraction in place. We have all sorts of bypath, and the main path is partially supportive, while I think the high-level good news is that there is an industry momentum towards convergence, and it looks like eventually everybody would agree that NSH is the way to go. Today, with Neutron, I cannot really directly control and manipulate an SDN controller like OpenDaylight that has that capability. We do have Tecker as a big tent project that works around that and kind of behind the scene connect the dots so that we could do this. But your perspective, everybody here may have different perspective, whether this is the desired outcome, a good approach, or a patch. What is really, I think the question in front of us is what is the right standard main way to do these kind of things. And then going to the next level up, if you think of the service as something that starts with some sort of a management and orchestration, which is Mano from telco Etsy point of view, then maybe it all has to start at the top, where I actually have a global picture of my topology. I have understanding of the consumer and all the entitlement or lack thereof that that consumer has, and how all of that applies. And some pieces of my solution may be proper, pure SDN, some may be OpenStack, and I need to stitch that together. So that's a snapshot.
Okay, so we only have about maybe at most 5 minutes left. Any questions from the audience? Please raise your hand and I'll walk the mic over. Anything?
If you could chain those questions in a service way.
Service function chaining for questions. Okay.
Okay, because no one asked any questions, so I'll ask one. There is a Geneve protocol, which sounds to me like it could fit both the overlay tunneling and the service headers. What about that?
So there is a proposal that I have seen in an internet draft to put all of the NSH information into Geneve TLVs, but speaking personally, I much prefer to carry the NSH header as payload in Geneve. So Geneve is a valid transport, but if I want NSH interoperability, it's much cleaner if I keep the NSH header intact across each transport. Yes, there are ways to encode service chains into MPLS label stacks. There are ways to encode service chains into Geneve. There are ways to compose service chains into VNIs. But if we use the NSH, we can get interoperability without trying to get n-squared mapping at all the boundaries. So while you could embed it in something else, and there's guys who want to embed it in Ethernet source MAC addresses, lots and lots of answers. In fact, that's the problem. There are way too many answers. And instead of trying to say, well, this is the definitive transport, well, you build your network one way, he builds his network a different way, I'd prefer to use NSH as the commonality and use the transport mechanisms that the network wants to use.
Just add one short comment while I fully agree with Joel here. You need to, I'm putting an IETF hat on. You need to distinguish, because open source we could do, you need to distinguish between service function chaining and the different transport mechanisms that are available. There's only one proposal in the service function chaining workgroup today, and that's NSH. There are multiple transport options. Geneve is one of them. That actually, there is a design team that is in formation right now as part of the NVO3 workgroup to resolve that issue. Regardless, as Joel pointed out, this is a proposed mechanism, would be good for all of us not to argue on bits and pieces, but to agree with something we are all going to move faster.
And then maybe let me take a different approach to the answer here. There's always the notion of headers have to be standardized because multiple devices have to interoperate. At the same time, we are working towards a new generation of type of data planes that they are programmable. The programmability may be driven because hardware is becoming more flexible, or the programmability may be driven because networking is happening more and more into the edge of the network, in the compute nodes, where you have more tools in terms of software data planes, programmable data planes, and so on. So from a practical point of view, we are a small company, we are PlumGrid. Of course, we are not as plug as influential into standard bodies as we would like. So somehow we have to be kind of followers and always react towards what the industry defines. So we took an approach saying, well, headers are like very, very, very strong positioning when you start thinking that you have to burn it into an ASIC. But if you have the luxury to have a programmable data plane, now the question is how do you react fast to the standardization efforts in a way that you can track them almost like the draft is done and you have a data plane that matches that implementation. And doing a mistake is not a big deal because you can change it. So in this way, it allows for a much more interactive thing. For example, Joe was saying, what if we use NSH values translated to TLVs in Geneve, or we put it into a payload? You say, well, why don't we try both? And why don't we see which one carries more things than that? So we had to take this approach more from a survival point of view. But at the end of the day, what happens is regardless the way you achieve a consensus on what's the way to go by adoption or by standardization has to happen. And now the thing is like how careful you are defining those headers versus like try and fail fast. And that will be based on the implementations that you have available.
Okay, do we have time to do one more question? I think so. All right, let's do it.
Yeah, hi. Just a question on, obviously with service chaining, we're introducing a lot more east to west traffic. So from your point of view, what solutions are you looking at from a security perspective? Now we've got this lateral movement. Are you introducing like micro-segmentation? I mean, how are you dealing with that aspect? Because that's the issue that I see with all these different points. So if you're going to introduce things like Palo Alto or some, inspection traffic, how are you dealing with that?
Maybe let me start on the use case. Going back to what I was saying before is when you say, how do we deal with security east-west traffic? Means that you have a use case in mind. Let's say that you have different tenants running different web applications on your cloud, and now you want a micro-segmentation solution that when you do service chaining, using the mechanism of chaining functions, you are going to carry the information of the identity of the compute workloads that you have into the network functions that you have. And this is where the metadata comes handy, because once you decided that you're going to standardize your service function chaining with a specific mechanism, now is the orchestration aspect on how your container or your VM running a website is tagged in a way that when the overlay is going to inject the metadata, it carries the metadata in a way that Palo Alto can consume it, for example. And now standards are important because if one network function vendor consumes .1q tags versus another one NSH headers, now the plumbing infrastructure, the SDN layer or the physical network layer that has to do the plumbing becomes much more complicated. So today this is the reality where we are. Different network function vendors are providing different mechanisms for integration, and the micro-segmentation companies like what PlumGrid offers into data centers have to deal with the complexities of the wall. So we have to figure out how to accelerate as fast as possible towards a standard like NSH and a proper integration model in a way that the network function vendors can develop one standard and the integration models become cleaner. And then you can attach it to microsegmentation, you can attach it to interfaces, to whatever you want, because it's how you hook the mechanism to the identity of the workloads that you have in your cloud.
Yeah. So let me just add to that. One of the things about the standard as opposed to a solution that somebody might sell is we have to recognize the range of needs. If a traditional IP service provider is doing this to add services in their data flow, then they are operating within a trusted network. They're not worried about securing the traffic against adjustment by elements of their own network. Not everybody has that security assumption. Other people have different assumptions. So there is a draft, for example, that shows how you can add an authentication information to the NSH header to authenticate the header and the content if you want to protect it from modification. But the default case, you don't use that. You use, because there's a cost to authenticating and re-authenticating and adjusting the signature when information metadata changes and all of the other things you need to do. Similarly, you could split your service functions and have one for each subscriber, and if a subscriber is a major tenant, maybe that's the right granularity. Other times you will want multi-threaded service functions and you trust them enough for them not to be adjusting the metadata that identifies the tenant because you as an operator worked with them and made sure that they're trustworthy. And so there's different environments and different solutions and different degrees of security. And when you're shipping things between two data centers, maybe you want to protect it with IPsec, even if you're not protecting it inside your data center. And that, again, because that's a transport, becomes a solution you can apply in conjunction with NSH.
Okay, great. I think that's all the time we have. Uri, Joel, Perret, thank you very much for being part of the panel. I also want to let the audience know, if you'd like to learn more about the topics, this is an excellent book. It just came out called Network Function Virtualization. A lot of the topics are covered here. We have 2 copies at the PlumGrid booth, so feel free to come by. And for additional information on NSH, you can also just Google IETF, NSH, and the draft IETF will pop up, and you should be able to get the entire draft in terms of how that works. So thank you very much, and have a great conference. Thank you.
Thank you.
Thank you, guys.
Thank you.